Hello everyone, myself Dr. Pradeep ISM, working as an assistant professor in Department of Chemistry at RNS Institute of Technology, Bangalore. Right, so in this video I am going to talk about this green fuels. I am going to talk about green fuels. Right, that is green energy or green fuels. Right, so before going to go to this actual topic, let me start from this. Right, so we all know that energy is one of the very important aspect of human activity. Right, so energy is one of the very much essential requirement of our modern life. Right, so earlier these energy demands were met with by muscular effort. Right, that is, in the older days people met these energy demands by muscular effect or wind energy or by water current or wood or by direct solar warming. Right, so with the extent of industrial civilization and modernization, these energy sources become less important and the fossil fuels like coal, lignite, petroleum, natural gas, etc. began to play a very important role as energy resources. Right, as energy resources. So nowadays the extent of energy consumption is related to the extent of industrialization of the country as well as standard living of its people. Right, so standard living of its people. Right, so people are consuming more and more energy in order to show their standardness. Right, so all these things made us to generate more and more electricity or energy. Right, so from this. Right, so nowadays the very important topic of discussion is energy production. So energy production and consumption and management. Right, so energy production, consumption and management. Right, so according to one approximation, so there occurs a tenfold increase in the energy consumption in the past 3 decades and it is expected to rise to 30-fold increase by in and around 2050. Right, so this is the challenging proportion to be tackled, right, by human beings. Right, so that's why we have to go for newer and newer ways to generate this energy. Otherwise all our activities will get hampered by one day. So because these fossil fuels, we in our country, India, we don't have resources of crude petroleum, so we are importing from the other countries. Right, so that's why we are to depend our own way of generating electricity or energy, then only we can survive in the near future. Right, so if you can list out the energy resources, right, which are present, if you can take all the energy resources which are present right now, they can be classified, right, they can be classified into fuels and non-fuels. They can be classified into fuels and non-fuels. Right, so fuels examples are this coal, crude petroleum, right, and then natural gas, right, and uranium, right, and you can say biomass, right, as a fuel under this category. So coming to non-fuels, so they consisting of solar and then wind and then tidal, or you can start with geothermal, right, geothermal, so tidal, and then biofuel, right, biofuel, etc. Right, so in this way we can classify. So the other way of classifying these energy resources is in this way. One is renewable energy resources, the other one is non-renewable energy resources. So non-renewable energy resources. Remember, non-renewable energy resources, right? So these non-renewable energy resources, all these fuels comes under non-renewable energy resources. See, except biomass, all these fuels will comes under non-renewable energy resources, right? All these fuels comes under non-renewable energy resources. So, and all these non-fuels comes under renewable energy resources. Examples are non-fuels, we can give like this. So for these renewable energy resources, we can give another name, that is non-conventional energy resources. Non-conventional energy resources, these are all conventional energy resources because we are using this from so many days, right? Almost all the peoples are depending on these non-renewable energy resources, right? As they are non-renewable, that's why there is a requirement to move towards renewable energy resources, because renewable energy resources are clean, continuous and renewable, and they are environmentally friendly, right? So why they are calling it as renewable energy resources? So, and they are calling it as non-renewable energy resources is, non-renewable energy resources are the one whose sources will get depleted upon mining, right? So if you keep using more and more these non-renewable energy resources, at one fine day they will get exhausted. They are called as non-renewable energy resources or conventional energy resources or fuels. Coming to renewable energy resources, these are the one whose resources will not get depleted upon any mining, right? They have huge amount of energy. You can utilize any amount of energy and convert that into useful form, still their resource will get full. So that type of energy are called as renewable energy resources, right? So at present we have to move towards these renewable energy resources, then only we will survive in the near future. Okay, so these non-fuels or renewable energy resources are only called as green fuels. So why? Because they are all obtained from natural resources, right? All those energy fuels or all those fuels which are, or all those energy which is obtained from natural resources, they are called as green energy, right? Green energy. And the corresponding fuels are called as green fuels, right? So examples are all these things, right? So if you can list out the green fuels which are present at present, there are 6 very, very important green fuels are there. So one is solar, the other one is wind. Actually here I forgot to write one more, that is hydroelectric power plant, right? Hydro I forgot to write. So hydro, and then geothermal, the 4th one, and then biofuel, and the 6th one is biomass. So these are the 6 most important green fuels or green energy which are there at present, right? We have to target more and more on these in order to generate more and more electricity, because they are clean, continuous and renewable, they are environmentally friendly, and their resources will not get depleted upon any mining. Okay, so remember. So coming to this, the past and future perspective of green fuels or green energy. So as already told, if you are using these fuels more and more, so already what happens, these fuels are based on crude petroleum, coal or other things. If you are using these fossil fuel based fuels, so what happens, they are going to release automobile exhaust gases, that is they are going to release air pollutant into the atmosphere, right? So if you can list out, if you are using more and more these fossil fuels, it is going to emit 5 major primary air pollutants into the atmosphere. So you can list out, like carbon monoxide will be released, right? Carbon dioxide is which is a very, very important greenhouse gas, you can list out here. So if you are using this, they are going to emit carbon monoxide, CO2, NOx, that is oxides of nitrogen, and then SOx, oxides of sulfur, and then hydrocarbons, and then particulate matter, right? So if you are going to use these, our environment will be polluted, right? So that's why there is a need for the invention of a newer method in order to generate electric current, and these newer methods are these non-fuels and renewable energy resources, right? So they are the very good alternatives to these fuels, that is conventional energy resources, in order to minimize the negative effect of these fossil fuels, right? So therefore there is a demand for generation of these renewable energy resources. So why? Because majority of the energy resources are environmentally friendly, and some that are such as this what is this, you can call it as green fuels. They are obtained from biomass origin or water molecules. So that's why through a variety of thermal, biological or chemical processes we are going to generate green fuels, right? So compared to the fossil fuels, these green fuels are also identical with those of petrol, diesel, kerosene, etc. So that's why they can be acting as a very good alternatives to these fossil fuels, which are very, very dangerous to the environment, right? So with that, and further, if you go more and more for these green fuels, it will encourage our agricultural industry, because some of the biomass and biofuel are produced from the agricultural crops. So it will encourage the farmers to grow more and more that agricultural crops. So we can utilize that. In that way also it is useful, right? So the very best. So after seeing all these things, right? So these are all the green energy or green fuels, and after seeing this, see the carbon containing, one thing is sure that these carbon containing fuels are non-renewable, right? And they are going to emit carbon dioxide and all these air pollutants, right? So that's why they are not environmentally friendly. So because carbon dioxide is very important greenhouse gas, so it is because of that reason there is a need for the developing of an alternative energy resource which is clean, continuous and renewable, which is clean, continuous and renewable, right? Renewable there, right, is required in order to meet global energy demand, right? So our hydrogen, here comes the word hydrogen. So hydrogen is one of the very, very important alternatives, right, to these fossil fuels, right? Along with this, see, hydrogen is the only promising alternative energy resource to these carbonaceous fuels, right? Carbonaceous fuels. So that's why in the next concept we can understand how this hydrogen can be produced by the electrolysis of water, right? Now we can take up this green hydrogen, right? So we have discussed about the green fuels, green energy, right, and conventional energy resources, non-conventional energy resources and all, and at the end we have concluded that green hydrogen or hydrogen is the very best example for alternative to these fossil fuel based energy resources. See, carbon based, as we all know that carbon based fuels are non-renewable and they are going to produce a lot of air pollutants such as carbon monoxide, carbon dioxide, NOx, SOx, etc., right? So that's why, so developing an alternative energy resource which is clean, continuous and renewable is required, right? So it is of required in order to meet the global energy demand. So in that sense green hydrogen is the very best alternative, right? So if you can see the properties why green hydrogen can replace these fossil fuels, is you have to understand these properties in order to understand that, right? So if you look at the properties of this green hydrogen, so green hydrogen is an ideal, highly efficient, clean, continuous and renewable energy resources and sustainable energy resource. So that is the first property of this green hydrogen, right? So coming to the second one, it is abundant from various natural resources such as biomass and water, right? So that is the second property of this green hydrogen. It is abundant in nature, right? We can convert biomass and water into hydrogen. So if you come into the energy content of hydrogen is around 123. There is a third property, 122 kilojoule per gram. So 122 kilojoule per gram, it is around 2.75 times greater than the energy from the fossil fuel resources like petrol and diesel, right? So this is where it will stand differently compared to the non-conventional energy resources. And the fourth property of this is the combustion product of this hydrogen is only water which is not a pollutant, right? Which is not a pollutant. Coming to the fifth property, this hydrogen can be used as a fuel in fuel cells in order to generate electric current, right? And sixth one is this hydrogen can be directly used to convert heat energy or electrical energy alone, right? And the seventh one is it is having a very good storage capability or high storage capability, and therefore it is considered as an alternative, a best alternative to these fossil fuels. So these are the definition and properties of this green hydrogen. Now let us see the production of green hydrogen by electrolysis of water, right? Production of green hydrogen by electrolysis of water. So first we can consider alkaline water electrolysis method, right? Alkaline water electrolysis method. Okay, so we can consider this method. See, in alkaline water electrolysis method, so if you come to the construction, see, anode is so nickel metal particles dispersed on porous carbon. Anode is nickel metal particles dispersed on porous carbon. So cathode is same nickel metal particles. So nickel metal particles, right, coated on porous carbon. So and the electrolyte is aqueous solution of KOH. Electrolyte is aqueous solution of KOH. And coming to the separator, so separator is porous dense anion exchange membrane. Porous dense anion exchange polymer membrane. Okay, porous dense anion exchange membrane is used. These are the components of this alkaline water electrolysis method. So if you can write the diagram, see, it is looking like this. So in this form you can it consisting of anode compartment as well as cathode compartment, right? Both these compartments are separated by a separator, right? It is separated by a separator like this. Okay, so this is all construction part, and this is this is the anodic part. So we can write like this, and this will be cathode. Right. So in between we are going to take an electrolyte. So like this, it is porous, so dense anion exchange membrane, right? So one can write like this, and then so this anode is connected to the positive terminal of the external DC supply, cathode is connected to the negative terminal of the DC power supply. So this is a DC power supply, right? So this will be anode, which is always written to the left hand side, and this is cathode, right? So and this is an anion exchange membrane. This is anion exchange membrane, right? And this is the aqueous solution of KOH, aqueous solution of KOH, that is the electrolyte, right? So like this one can write the construction, right? So now coming to the working. So as we all know that the electrolysis of water is a non-spontaneous chemical reaction. So that's why a DC power supply should be applied, or DC power supply should be connected, right? So anode is connected to the positive terminal, cathode is connected to the negative terminal, right? See, now at the cathode, water will get reduced by electrons, thereby it is going to produce hydrogen and hydroxide ions, negatively charged hydroxide ions. So that we can write it here. So if you can write water, that is 2H2O, if you are supplying, then hydrogen will be released, and negatively charged OH minus ions, negatively charged hydroxide ions will migrate through this electrolyte and the membrane, that is anion exchange membrane, and will reach cathode. So at the cathode we are going to get oxygen will be produced, right? See, if I explain once again, see, electrolysis of water is a non-spontaneous chemical reaction, so DC power supply is used, right? Anode is connected to the positive terminal, cathode is connected to the negative terminal, and at cathode water is reduced by electrons to hydrogen and negatively charged hydroxide ions. These negatively charged hydroxide ions move through the electrolyte and through the separator and will reach cathode, and at the cathode these hydroxide ions will undergo oxidation to produce oxygen and then water molecules along with the liberation of electrons, right? So this is what it is going to happen inside these working conditions, right? So if you can write the reactions, so here I am going to write, see, at cathode, see, first we can take up cathode reactions. If I can write the cathode reactions, see, it will be like this. See, two molecules of, so I will write this in short, H2, and this is cathode, okay, and this is like 2H2O. Okay, see, at cathode what reaction is going to take place? These water molecules, that is 2H2O, will get reduced by the electrons, that is 2 electrons, that give rise to what? Hydrogen and 2 molecules of negatively charged hydroxide ions, these H2 and hydroxide ions. So now these hydroxide ions move through the electrolyte and polymer and separator and will reach anode, right? See, at the anode, this is at cathode, this is at anode, see, at anode, right? These negatively charged, hydroxide ions undergo oxidation, so thereby they are going to produce water molecules, that is of O2 will be produced, and water molecules like H2O, and 2 electrons will be liberated. So electrons will be liberated over there. So if you can write the net cell reaction, if you can write the net cell reaction here, see, it's a combination of these two half cell reactions. So 1 moles of water and 1 moles of water will get cancelled. OH get subtracted here, and this will be going, and whatever remaining is that electrons will also get cancelled. So H2O will give rise to H2 plus half O2. H2 plus half O2. So overall water molecule will split into hydrogen and oxygen in 2:1 ratio, right? In 2:1 ratio. So this is the process which takes place in alkaline water electrolysis. As we are taking aqueous solution of KOH, the method is called as alkaline water electrolysis, right? So coming to understand the advantages of this method, advantages, just I will read out. So this list out these advantages. So as we all know that alkaline water electrolysis is one of the cheap and efficient method for the production of hydrogen. This uses a cheap electrode material such as nickel metals, right? And then it is going to form pure carbon free hydrogen is produced by this method. That will be the third advantage. And the fourth advantage is excess cheap current from renewable sources such as solar power, right? Or solar power can be converted into green hydrogen and it can be stored as chemical energy. So in this method, so these are all the advantages of this alkaline water electrolysis method, right? So it is one of the important method in order to produce green hydrogen. So green hydrogen is of very much demand nowadays. People are moving towards this hydrogen fuel. So the next method for the production of green hydrogen by electrolysis of water, that will be proton exchange membrane electrolysis. Proton exchange membrane electrolysis. Proton exchange membrane electrolysis. See, if you look at the construction of this cell, this electrolysis method, here you can write construction similar to the previous method. So anode, here anode is iridium metal particles. Iridium metal particles dispersed, iridium metal particles dispersed on porous carbon. This is anode, and then cathode will be platinum metal particles, coated on porous carbon, right? So here in this method, both electrolyte and separator both are same, so that will be a porous proton exchange polymeric membrane, right? So porous proton exchange polymer membrane, right? So polymer membrane, usually a fluoropolymer, right? So polysulfonated fluoropolymer, okay, so fluoropolymer membrane will be used, right? So it is used both as electrolyte as well as separator, right? So this is a very good conductor for ionic conductor, and it is conducting protons, but it is a bad electronic conductor, right? So it is going to prevent the spontaneous recombination of H2 and O2, right? So similarly, in the previous method, this anion, the separator anion exchange membrane is that is a good ionic conductor for hydroxide ions, and it is a bad electronic conductor, and that is also prevents the spontaneous recombination of H2 and O2. So similar to this method. So coming to the construction, So construction is almost same with that of alkaline water electrolysis. So here the only difference is both electrolyte and the separator both are the porous proton exchange polymeric membrane, right? So here this is anodic part, no doubt, and this is cathodic part, and whatever it is there in the middle, it is all the proton exchange polymeric membrane, right? It is it is a very good ionic conductor for H plus ions, that is for protons, and it's a bad electronic conductor, right? So we can write like this. In this way you can write the construction, right? So it is an anode, this is cathode, okay, anode and cathode. So as water electrolysis is a non-spontaneous chemical reaction, so DC power supply is to be used. It is a DC power supply, and here in this case, so anode is connected to the positive terminal and cathode is connected to the negative end of the DC power supply, right? So coming to the working of this method, proton exchange membrane electrolysis method, in this case this side is anode and this is cathode, isn't it? So if you circulate deionized water or demineralized water at the anodic compartment, then what happens? It will undergo oxidation, thereby it is going to produce oxygen and hydroxide ions, H plus ions, oxygen and H plus hydrogen ions, right? So oxygen will be formed here and hydrogen ions will be formed. So that positively charged protons, right? That's why the method is called as proton exchange membrane electrolysis method. So that positively charged protons will migrate through the electrolyte and the separator. Both are same in this case. It is a fluoropolymer, right? And will reach cathode, right? And they will reach cathode. At the cathodic site they undergo reduction, right? At the cathodic site they undergo reduction, thereby they are going to produce hydrogen gas, right? H2 will be formed, right? So this is the method and this will be DC power supply. So DC power supply, okay, almost similar to that. The only differs only in the fact that it is a proton exchange membrane polymeric membrane electrolysis, right? So if you write the reactions, see at anode, right, water molecules, we are going to circulate water at the anodic compartment, isn't it? So water molecules undergo oxidation, so that will be 2H2O, that give rise to, so O2 plus 4H plus 4 electrons. So 4H plus 4 electrons. Here I am taking 2 moles of H2O, that's why we are going to get O2 and 4H plus 4 electrons. So these H plus ions, that is protons, migrate through the electrolyte as well as through the separator and will reach cathode. At the cathode they undergo reduction, thereby they are going to form H2, right? So these 4H plus 4 electrons, right, undergo reduction, thereby they are going to form 2 moles of H2, right? And the net cell reaction is a combination of these two off cell reaction, and we can write like this will get cancelled and whatever remaining is 2H2O, that gives rise to 2H2 plus O2, right? So in this way hydrogen molecule will be electrolyzed or split to form H2 and O2, right? So this is also one of the very important method for the production of green hydrogen by electrolysis of water, right? So coming to the advantages, right? So how one can list out the advantages of this? The first advantage is, as we are using a solid porous proton exchange polymeric membrane, the use of liquid acid electrolyte will be minimized or stopped. So that's why there will be no question of leakage of the acid is going to take place here. And then this polymeric proton exchange membrane, it is chemically stable and inert and non-corrosive in nature, right? So it is chemically stable and non-corrosive. So that's why that will be the second advantage. And pure carbon free hydrogen is obtained by this method also, and that will be the third advantage, right? Pure carbon free hydrogen will be obtained in this method. Here this polymeric proton exchange membrane is stable, chemically stable and non-corrosive, right? So here the use of proton exchange membrane reduces the use of liquid acid electrolyte, right? And fourth one is the excess cheap current from the renewable sources such as solar power can be converted to hydrogen and can be stored as chemical energy, right? So like this it can be understood, right? Anode, cathode and electrolyte. It differs only in the fact that here we are going to utilize porous proton exchange polymeric membrane. It is made up of fluoropolymer and it can act both as electrolyte as well as separator, right? So understood?